Okay, in looking at the models below, we're looking for the most reactive model. And in looking for the most reactive model, we want to look at our periodic table. And on our periodic table, the most reactive group is going to be in group number 1. Now, in group number 1, we remember that there are 1 valence electron. In group number 2, there's 2 valence electrons. And then in group number 13, there are 3. And so on. 4, 5, 6, 7, and 8 valence electrons in group 18. The most reactive group on the periodic table is the alkali metals, which are the metal group right here. Right here. These metals right here are the most explosive group and the most reactive group on the periodic table. The ones with 1 valence electron. So if we look at these models, model A, B, C, and D, and we count the valence electrons in these models, we can count and see that model A has 1 valence electron. Model B has 1, 2, 3, 4, 5 valence electrons. Model C has 1, 2, 3, 4, 5, 6, 7 valence electrons. And D has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So again, model A has 1 valence electron. Model B has 5 valence electrons. Model C has 7 valence electrons. And model D has 8 valence electrons. So in knowing that our valence electrons, the least number of valence electrons determines the most reactive atom, which one of these models would then be the most reactive model? And the answer would be model A, because model A only has the 1 valence electron, therefore placing it in the periodic table in group number 1 and making it part of the alkali metals, making it the most reactive model in this picture. Okay, and looking at the same models A, B, C, and D, we're now looking for a model that represents an atom, a stable atom that will not react. If we look at our periodic table, we will remember that the most stable group is right here in group 18. Group 18 is our noble gases. And the noble gases are the most stable group on the periodic table. Now, the key thing about our noble gases is that our noble gases have 8 valence electrons. We just talked about the most reactive group being right here, our alkali metals with 1 valence electron. And our stable group is on this side with 8 valence electrons. So our stable group, our non-reactive group, is our fat dogs. Because remember, our fat dogs, the noble gases, they're fat. Their shell is full. Their belly is full. It's full of 8 valence electrons. Remember, they lay down to eat. They have 8 valence electrons. And then our skinny dogs, the hungry dogs, are the most reactive group. Right here in group 1 with 1 valence electrons, they're the skinny dogs. So they're the most reactive group on the periodic table. So the fat dogs, the most stable group, the one that doesn't react with anything, have 8 valence electrons, and our skinny dogs have 1 valence electron. So, in looking at these models, A, B, C, and D, and knowing that model A has 1 valence electron, model B has 5 valence electrons, model C has 7 valence electrons, and model D has 8 valence electron. Which one is the most stable atom? And the answer is our fat dog model. The most stable model is going to be model D with 8 valence electrons, because the skinny dog model, the most reactive group, remember, was model A. So the most stable group in this model, on these models, A, B, C, and D, is model D. Okay, based on the periodic table, how do you find elements with similar chemical properties? Remember, when we're looking for chemical properties, we're looking at our valence electrons. And our valence electrons are arranged, our elements are arranged on the periodic table according to their groups. And the groups have to do with the valence electrons. And the groups run vertically on the periodic table. So when we are looking for elements with similar chemical properties, we are looking at our upstairs, downstairs neighbors. We are not looking at our next door neighbors. So we're looking for elements that are similar here in our groups. The groups upstairs, downstairs are the ones that tell us similar chemical properties. So if we are looking at the periodic table and we are looking at carbon, silicon, phosphorus, and nitrogen, and we wanted to find an element that reacts like nitrogen, would we look to carbon, silicon, or phosphorus? Remembering that the chemical properties run in groups, upstairs, downstairs neighbors. So our answer would be, we would look to phosphorus. Nitrogen and phosphorus would react more similar chemically than nitrogen and carbon or nitrogen and silicon, because nitrogen and phosphorus are in the same group. So when we're looking for similar chemical properties, we are looking upstairs, downstairs. We are looking in the columns, in the groups, to find elements of similar chemical properties, because the elements have to have the same number of valence electrons in order to act similar chemically.